Let us construct a triangle with sides 3, 4, and 5 centimeters as its side lengths. Before starting the construction, let us try to understand the logic behind it. Mark any point as A. Now, try to locate another point B. That is situated 5 centimeters away from A. If you try this out by yourself, you can notice that there are many such points. And all such points lie on a circle of radius 5 centimeters and center at A. Conversely, any point that lies on a circle with radius 5 centimeters and center at point A is always at a distance of 5 centimeters from A. Coming back to the original problem. First, construct any one side of the triangle. In this case, we have chosen the side with length 5 centimeters. Since the third vertex lies 3 centimeters away from point A, we mark all the points that are situated 3 centimeters from point A. Similarly, the third vertex lies 4 centimeters away from point B. We mark all the points that are situated 4 centimeters from point B. The points of intersection of these two circles, C and C', satisfy the distance criteria. That is, they lie 3 centimeters from point A and 4 centimeters from point B. Notice that drawing the whole circles is unnecessary. If the approximate location of point C can be estimated, we can draw arcs instead of circles. Draw an arc with radius 3 centimeters from point A, and another arc with radius 4 centimeters from point B. The point of intersection of both the arcs is point C. Join the vertices to form the triangle. There is another point C' that satisfies the distance criteria. What is the difference between both the triangles? Can you figure it out?